It will be hard to completely understand the idea of objects unless one has understood the concept of the this keyword in JavaScript. In a language like Java, this is bound to the current object, alright? But in JavaScript, it is bound to different objects based on the context in which it is used. Also, the way this is bound to an object in JavaScript varies with the strict or non-strict mode. But mostly, people don't write JavaScript code in the strict mode, so I'll not be dealing with that here. As said, this keyword is bound to different objects based on how it is used. Let's categorize the usage into two parts: the global context and in a function context. In function context, it can be further categorized into whether it is used as a simple function or whether as a method on an object or as a constructor function. But let's start with the most straightforward case when used in the global context. When the this keyword is used in the global context, that is outside any function, for example, directly in a script. Like here, let's just log this. So here, this is not used inside any function. Hence, it is said to be used in the global context. And right now, this keyword is bound to the global object. So if we log it, we can see that this is referring to the global window object. But we can also use the this keyword inside a function, which is said to be used in a function context. Now, there can be different objects that this can be bound to. So let's consider all the cases one by one. The first one is just a straightforward simple call to a function. Let's say we have this test function which just logs this object. If we call the test function, this refers to the global Windows object. Alright? By the way, if you use JavaScript in the strict mode, it will be undefined. But because commonly we don't use strict mode, I'm not getting into that. But what is it bound to if it is used inside a function that is a part of an object? That is, what if the this keyword is used inside an object method? Let's create an object. Let's call it a circle. And let this point to an object having a radius. And let the radius be 3. And an area property, which is a function that calculates and returns the area of the circle. In this area function, which is acting like a method for this object, we are referring to the radius property that should belong to this object. Alright? And if this object does not have a radius property, we will get an error. But right now, we do have this radius property, so it would work just fine. So inside an object method, the this parameter is bound to the object on which this method is called upon, which is this object that we created. By the way, we don't need to have the radius property defined in this object at compile time. Let me just execute this statement again, but without the radius property. And right now, if we call the area function, we get an error, of course, because this object doesn't contain the radius property. Now let's add this property as another statement. And now if we call the area method, it will work just fine. This is another thing about dynamic languages, where references do not matter at compile time, rather at execution time. Alright, now if we look at this test function which we wrote earlier, just by looking at the function we cannot be sure what the this parameter will refer to. And this point is very important to understand. So when we write the function and use the this keyword inside it, we cannot be sure if it will refer to the global window object. It is only when the function is called and how it is called decides what the this param is bound to. Let me add another property to the circle object and let me just call it f, which is equal to the test function. Notice that we are not assigning the function call, rather the test function itself to f. And now if we call a circle.f, what do you think will get printed? Well, now that this keyword is bound to the circle object, because it is through this object that the function has been invoked. So again, we can only determine what this parameter is referring to only by looking how the containing function has been called. And this idea is heavily used in DOM manipulation, etc. And to understand it, let me show you a quick example. Now here we have a couple of span HTML elements and a text input element. And we have defined a function which just changes the background color of an element to blue. Now here we have used this parameter, which is not bound to anything right now. In fact, right now we don't even know whether the object that it will be bound to has a property named style. Okay? But then when the page loads, we call this load function, which assigns this function to the onClick handler for all these three HTML elements. We will learn about DOM and events in detail in another chapter. Right now, I just want you to get the idea how this function is attached to some objects, which are the click handlers. So that when we click on any of these elements, this function will be invoked through that object on which we have clicked. And hence, this will then refer to that object which was clicked. So let me open this HTML in a browser and click the input text box. And the background color of this alone has changed. Alright. Similarly, we can click on these span elements to show how the background color changes for those elements. So this is a good use of this keyword, using which we have written a generic function, and then that function can be attached to whatever object we like. Then what about using this keyword inside a constructor function? Well, in that case, it gets bound to the object being created, and that's what we will learn in the next lecture.